Hey everyone and welcome. If you're on the path to getting your ISTQB certification, you are in exactly the right place. Today, we're going to tackle one of the absolute core skills for any tester, really, for your exam and your career. We're talking about the journey of taking a simple requirement and turning it into a really powerful test case. So, let's jump right in.
So, here's our game plan. We've got 4 main stops on this little journey. First, we'll lay the foundation with analysis and design. Then, we'll look at the actual workflow a tester follows. After that, we'll peek inside the tester's toolkit. And finally, we'll see how traceability connects everything together. Simple as that.
Okay, so this right here, this is the big question, isn't it? How does a professional tester actually take a simple requirement, just a line of text, and magically turn it into a powerful test that proves something works? That's the whole point of what we're doing here. And by the end, you'll know exactly how it's done.
All right, Section 1, the foundation. We're talking analysis and design. Look, before you can build a house, you need to understand what bricks and mortar are, right? Same thing here. We got to get the fundamentals down before we can do anything else.
So, first up is this thing called a test condition. The easiest way to think about it is it's the what. It's the thing you're trying to test. It could be a function, a specific feature, maybe a quality attribute like performance. You're basically looking at the requirements and asking yourself, okay, what specifically can I test here?
And that naturally leads us to the test case. Now, if the test condition was the what, then the test case is the how. This is the nitty-gritty. It's like a detailed recipe for a chef. It tells you the exact ingredients, your input values, the prep work, your preconditions, and most importantly, what the finished dish should look like, your expected results. It's the step-by-step guide to run one specific test.
So let's just nail this down because it's so important, especially for your exam. The test condition asks, what can we test? It's high level, like test the login functionality. The test case answers, how will we test it? It's super specific. Given username test user and password 55 word, when I click login, I expect to see the main dashboard. See the difference? What versus how. You got to know this.
Okay, moving on to our second stop, the tester's workflow. We've got our building blocks, the what and the how. So now, how do we actually put them together in a real-world, step-by-step process? Let's take a look.
Really, it boils down to this logical 3-step flow. Step 1 is test analysis. Think of this as the reading phase. You comb through all the requirements, what ISTQB officially calls the test basis, and you pull out all your test conditions. Step 2 is test design. This is the writing phase. You take those conditions and you write your detailed test cases. And finally, step 3 is test implementation. This is the organizing phase. You bundle those test cases into logical scripts or procedures, getting everything ready to actually run. See? It just flows, one step to the next.
Now, I have to stop here and emphasize this quote because it's absolutely critical. You have to define your expected results before you run the test. Why? Because there's a huge trap waiting for you if you don't. It's called confirmation bias. You run the test, you see a result that looks kind of right, and your brain just goes, yep, that looks good, and you move on. You might have just missed a bug. Defining the expected result up front forces you to be a scientist, not a cheerleader. It keeps you objective and prevents those nasty false passes.
All right, time for Section 3, a tester's toolkit. So we know the what and the how, and we know the process. But how do we actually come up with good test ideas? How do we design tests that are smart and efficient and have a high chance of finding bugs? Well, that's where our toolkit comes in. We have specific techniques for this.
The ISTQB breaks these techniques down into 3 main categories, and it's all about where you get your information. You've got specification-based, which we call black box, then there's structure-based or white box, and finally, you've got experience-based techniques. Think of it like this. Black box looks at the system from the outside, white box looks at the code on the inside, and experience-based, well, that comes from your own brain and gut feel.
Let's focus on the 2 big ones, black box and white box. The analogy is perfect. With black box testing, you imagine the software is a completely sealed black box. You have no idea what's going on inside, no clue about the code. All you can do is put stuff in, inputs, and see what comes out, outputs, and check if it matches the user manual. Now, with white box testing, it's like the box is made of clear glass. You can see all the wires and gears inside. You use your knowledge of that internal structure to design your tests.
Okay, let's dive into a classic black box technique you absolutely must know, equivalence partitioning. This is all about working smarter, not harder. The main idea is, if the system is supposed to treat a whole group of numbers the same way, why would you test every single one? That's a waste of time.
Instead, you just divide all possible inputs into groups, or partitions, where they should all be treated equally. Then you just pick one test value from each group. Boom, maximum coverage, minimum effort.
This postal rate example makes it super clear. Take a look at that second row. The rule says any weight between 10 and 50 grams costs 35 pence. Now, are we going to test 11 grams, 12 grams, 13 grams, all the way up to 50? No way. We just pick one number from that group, say 42, and test it. If 42 works, we assume they all work. We do that for each valid group. And just as important, we create an invalid partition, like trying a weight of 102 grams to make sure the system handles errors correctly.
Okay, so equivalence partitioning is great, but there's a little secret developers know, and testers know it too. Bugs love to hide right at the edges of these partitions. You know, where the logic changes from one thing to another? That's where things get tricky. And that's exactly why we have another technique called boundary value analysis, or BVA. It's the perfect partner for equivalence partition.
So how does it work? It's simple, but it's genius. Let's look at that boundary at 10 grams. Instead of just picking a random number, BVA tells us to test 3 specific points. We test the value right on the boundary, so 10. We test the last valid value just inside the boundary, which would be 9. And we test the first invalid value just outside the boundary, so 11. By testing right around that edge, you are so much more likely to catch those classic off-by-1 errors that programmers sometimes make.
And for our final section, let's talk about the glue that holds this whole process together: traceability. This is what connects all the dots and makes sure that when we go from a big list of requirements to a big list of tests, nothing, and I mean nothing, falls through the cracks.
So what is traceability? It's really just the ability to link everything together. But here's the key term you need to remember: bidirectional. It has to be a two-way street. That means you can start with a requirement and trace forward to see which tests cover it. And you can pick any test case and trace it backward to prove which requirement it's for. Both directions are equally important.
And this is what that chain of evidence looks like. It starts with the requirement. That requirement is linked to the test condition, the what we're testing. And that test condition is linked to the test case, the how we're testing it. It's a clean, unbroken link from the original business need all the way down to the specific steps a tester performs.
So why should you, as a tester, actually care about this? Well, for 3 huge reasons. First, it's your proof. It proves you've covered every single requirement. No gaps. Second, it's a massive time saver. Imagine a requirement changes halfway through a project. With good traceability, you know exactly which tests are affected. No guesswork. And third, it's how you communicate. It lets you confidently tell your manager or your client, yes, we have 100% test coverage for these features, and you can prove it.
Look, at the end of the day, this whole journey, from requirement to test case, it's about so much more than just finding bugs. Any script can find a bug. A professional tester builds confidence. You build confidence in your team that you're building the right thing. You build confidence for your stakeholders that their investment is sound. And most importantly, you build confidence for the end user that this software is going to work. That is your real job. And now, you're ready to start.